So today we are going to be talking about Django. Django is a framework that allows us to write Python code and create web applications. With Django, you can create a full stack application. So it allows you to build both a backend server that you can make HTTP requests to, as well as front-end templates. So these templates are in the form of HTML files and JavaScript files, and those can communicate with the backend within the same project to make a full stack application. So today we're going to start off with just the backend part. We're only going to create a server. We're going to create a few endpoints that we'll be able to access from our browser window. Before we talk about that, a part of us developing in Django, something that will help us do that is something called a virtual environment. So a lot of developers are usually working on a variety of different projects at the same time. So you're working on, even if it's in the same language, let's say you're working on Python projects. One project that is like maybe a greenfield project, which means it's brand new, uses a version of Python 3 versus an older project that you're working on in a different place could be using Python 2. And you don't really, and on your machine itself, you have like Python 3.8 or something like that. So a way to be able to keep developing developing with each project in its own environment, you can create these things called virtual environments. So these virtual environments are kind of like a container that wrap around our project that ensure that whatever we install inside of this container stays contained within that. So I can install, I can have the newest version of Python 3 in that container. And when I run my project, I would have to run my project in that environment. That allows us to kind of separate working environments. There's a metaphor of, think of it as a placemat at a dining table. And the dining table is for babies. And so the baby can eat and make a mess and do whatever, and you can just take the mat and throw it away. So these virtual environments are going to be a singular folder that contains all of your modules, all of your Python code, whatever libraries you want to install. So let's take a look at how we can create one. So when we install Python, so I can say type Python 3. So I have Python installed here. And usually when we install Python, there's also a separate folder that has all the modules, all the libraries and stuff like that. So for now, when using a virtual environment, we're able to make kind of like a smaller version. It'll make sense when we're seeing it. So let us run this command. So Python -m for module. I'm gonna make my screen a little bigger so you guys can see. Okay. I'm actually gonna just, okay. So Python -m, and then the module is called ven, so virtual environment. This will create a virtual environment for us. And all we have to do is give it a folder name. We can also give it a path and a folder name. So we can say we want it into this folder inside of another folder called vens, I don't know, like virtual environments, and then slash.
Does that folder need to exist before you do that? Or will it build the directory structure as well?
I think it might need to. Well, we can test it out. And then I can call it my project then. Oops. Oh, I forgot I didn't set my aliases yet. Okay, so we did not need to set it. It actually created it for us. So now inside of here, we have a folder called Vens. And inside of that, we have another folder called my project Ven. And this just holds a bunch of configuration files. The one that we will care about is inside the binary, and it has an activate script that will allow us to activate our virtual environment. So again, our virtual environment is just a folder with a specific version of like a new version of Python. And then when we activate it, whatever we run when it activates, it changes the path of our shell. So let me activate it real quick. If you're on a Mac, you do source, and then the path that you have. So I have Vens, my project, and then so in Mac, it's going to be inside binary or bin/activate. And there we go. So when we activate it, we see over here the name of the virtual environment. So what this does is it allows you, now everything that you put into your terminal here will go through this virtual environment. So if I have a specific version of Python installed here, I have like, I have pandas installed here. I used pip in here, so I will be able to access pip, pandas through this virtual environment, versus if I was just on my regular shell. So to deactivate, it's deactivate. So now I'm back to my regular path. So here, maybe I don't have pandas. This is not a way to find it out. But anyways, yeah, that is kind of how these virtual environments work. Questions about this? I didn't go into too much detail, but kind of just an overview.
When you activate and deactivate, does your work persist and does it stay at the same state that it was when you left?
So the thing that we care about staying in the same state is our dependencies, the libraries that we've imported, the version of Python that we're using in this specific virtual environment, and those do stay the same, yes. So if I go back to a virtual environment that I created like last cohort and I was working with that, all the stuff that I had installed through that will still be in there. All the modules will be in there. For Windows, if you want to activate it, you would have to activate it through, so it's just the path. So then my project then, and it's going to be under scripts/activate. So yeah, that's how you get it on Windows. Any questions?
Can you show again how when you activated it, what did it did and stuff? Because I looked away for a minute.
What it did? Okay, yeah. So let me clear my. Okay. So to activate, I'm on Mac, so I'm gonna do source./vens. I don't want to keep it in a nested folder. I just want it to be in one. I'm gonna delete this one. Oops, did I delete it all? I did. Okay. Let's just demonstrate it again. So this is through my regular command line. So I'm gonna do Python 3-m vents, and I will create one called my environment. Oh, oops, it's just vent, not with an S. Okay, so now I see that it has created a folder here. And now to activate it, I can say source and then /my environment. bin, and then activate. If I. There we go. So now, to know that your virtual environment is on, you will see the name of it in parentheses on the left side here.
If you create directory structure, do you create it underneath the virtual environment or the non-virtual environment?
What
So
do
if
you
you type make directory here, where will it create it at?
it'll create it in your file, like in your regular files. This will just affect like the Python module that you're running. So this is attached to pretty much Python. So if I say, so earlier I didn't have access to Python, just regular Python. And so now I have Python as a keyword because that was what was installed with the virtual environment. It automatically did that.
Zainab, can you pip freeze here just to see everything that you have
Mhm.
inside of your environment?
So pip, if you guys haven't used it, I think you probably have. Pip is I forget what it stands for, but it pretty much allows you to install libraries and modules for Python from the command line. So if I say pip install Django, which is our next step that we have to do, it installed Django. So the way I know if it's installed here is I can do python-m Django and it'll tell me like, so it recognized Django and it gave me the commands that I can do with it. Versus if I was outside, I don't think I have Django installed unless I made, yeah, oh, that's the Python command. Python 3, yeah, no module with the name Django.
So even though you just downloaded it
Mhm.
into your environment, it didn't necessarily download into like your overall machine.
Exactly. It's
Okay.
it's just attached to my virtual environment.
Okay.
So if we were to install an application via pip, it only exists in this virtual environment.
Yeah. So if you do it through like while the virtual environment is on. So if I had like at this line where the venv was on, then I can do the install and it would only stay within that virtual environment. But if I did pip install out here, then this will be globally for whatever Python version that I have installed. So if I did type Python 3, and then let me try doing it when my virtual environment is on. So source / then even though I've done this so many times, I forget sometimes what I have to do. Okay, so the virtual environment is on, and if I say type Python, so I have a different path if you see. So the original Python was here, but now I did the same exact command and I get this folder right here. So this is where my Python 3 is living, which is pretty cool. So this allows you to isolate your environments based on the project that you're working on. So you can keep track of versioning and libraries and stuff like that, and it doesn't get too messy. Questions about this? Okay.
So I have a question. When you're doing source activate, instead of using the path to like where you're going to your project folder and then /bin/activate, could you change directories instead to go into your project folder and then into bin and then just do source activate?
So this is not going to be our project folder. This is going to be our virtual environment.
Oh, okay.
Yeah. So my project folder here is this. Or actually, I haven't created my project yet, but this is my overarching like container of my project / virtual environment, which I was actually going to just touch on. So some people put their virtual environments close to the project that they're going to develop. Other people put them in a separate folder on their computer, and then that allows them to hold all of their environments in one place, and you don't have to deal with putting this in a git ignore. So if you have, well, I have a git ignore here, so I can just say my environment. So you typically don't want to include this in your project when you're pushing it to GitHub. So the way that you actually get your information, like how do I know what libraries I need to use or something like that? This is why we would use pip freeze. So pip freeze gives you your installed libraries. If you do pip freeze, I think it's -r, and then you name it requirements. Oh, so I think it's just requirements. .txt. So this is the general way. What this is doing is pip freeze gives you all the modules that are currently attached to your environment. And then -r is going to be, I think, to create a requirements doc out of it. And this is the name of a requirements file. Message file is good. Okay, hold on. I think I have to put this. So this pretty much pipes in. So when I did just pip freeze here, it spat everything out in the terminal. But if I do this, it pipes all of the output into a text file. Hold on. Oh, never mind. Okay. There's no -r. That is when I'm trying to use it. Apologies. Okay, so it's just pip freeze and then into a requirements.txt. Now, if I open this, I see my 3 modules that were installed when I installed Django. So yeah, some people put their virtual environment closer to their project. I previously have put it in, let me show you guys real quick. I put it in my base folder just because it's easy to access, like tilde. I don't think this is a thing in Windows, but you can do tilde/, and then I have my virtual environments. So my events folder, this is the one that I created. And then inside of here, let me just CD into this. Okay. And then I have a bunch of different virtual environments that I had created. And this just makes it easier to keep track of them and delete them if you want to. So yeah, either or is better. I think this might be a little more manageable, so you don't have like a bunch of different virtual environments in different folders, and you can keep track of where they are. But yeah, I went through quite a bit. Any questions?
Can you explain the requirements folder one more time?
Yeah, let's install a few more things and then we'll do that.
Okay.
So usually actually you call the pip freeze once you have your project, and I haven't created my project yet, so let's do that first. Let me try to find, okay. W4D5. No. There we go. Okay. Okay, so far, all we've done is create a virtual environment. And in that virtual environment, I did pip install Django. And this allowed me to install the Django package, and it installed certain dependencies, so certain things that Django uses itself. Okay, so that's all good. So now if we do Python-m Django, we're going to see a list of secondary commands, so stuff that we can do with it. A lot of it you're not going to use. We will talk more about like dump data, we'll talk about load data. Make migrations, you will use run server is one of the ones that you're going to be using quite a bit. Start app and start project are also very important. So let's start up a Django project. Here, let's do Python-m. Oops, Django. Start project. And let's give it a name. Call it simplest project. I don't know. Actually, I don't know the convention if it should be an underscore or a dash. I'll just do this. Simplest server. Okay, so it was not a valid identifier. So let's try underscore. There we go. So an underscore works for the project name. A dash does not. Okay, so when we did this, that's fine. I was going to try to just open it here. So what this did when we ran start project, it created a project with that same project name. And so this folder will have two things. It'll have a manage.py, which is our pretty much our main access to being able to run the server. We won't actually need to look at this code. I don't think we need to change anything here at all. But it's, yeah, we will be calling this file, but we won't really be looking at the code at all. And it also creates a what is it called? A subfolder for the main management of your project. So it has an init.py, which I don't think I've ever touched. But the ones that we will for sure look at is going to be the settings. It's a little better. So it'll be our settings, which there's a lot of stuff here. You don't have to understand it right now. When time comes, we'll understand it more. So we have the settings and we have our urls.py. And this is where we will be setting what our paths will be for our APIs or for our HTTP requests, which is kind of the same. All right. So now we've created a project. We usually have to do an app within a project. So Django has this weird, it's not weird, I find it a little weird, but has this model of doing things. And usually you create a project and then you create an app for each like big functionality of your project. So if you had like, I don't know, I'll bring a better example when we talk about the apps tomorrow or Monday. But yeah, so we usually create a project, and within that project, you have an app, and that app is what actually does your functionality. So if you have like your Amazon, let's say, and you're making your application through Django, you would have your entire like Amazon be or entire Amazon project be a project. And then let's say the e-commerce side is an app, and the Prime Videos is a different app, and AWS is a different app. So each one has its own type of functionality, but it all kind of is within the same umbrella. But today we want to do simple things. So let's do that. So pip freeze will allow us to record all the dependencies that we're using with the in this project. And really for right now, we only need to install Django, which we did already. So I'm just going to call pip freeze again. I'm actually going to go into my project, cd, into the simplest server, and then pip freeze. And then I'm going to pipe it into a requirements dot requirement. Yes, .txt. Okay. So yeah, your requirements is usually going to be in here instead of there. So I'm going to just delete this old one. So you just go into this folder, the main folder, and then you can do that, and we can look at what our requirements are. And it's still the same thing because we haven't installed many things yet. So why do we need these requirements? Can anyone tell me? Or can anyone guess?
To recreate the environment when you're working off someone else's code.
Exactly. So when we push our code, we're not going to include our virtual environment. So let's say you're working on a team of 2 and you start off the project, you set up whatever requirements you need, and then you do pip freeze like this, and then you push it up to GitHub without your virtual environment. So your team member will now take that project, and then we'll call, I think pip install -r, and then you're going to send in the file name, so requirements.txt. And this will install everything inside of here automatically. So you don't have to look at the list and do pip install this one, and then pip install this one. This will allow you to just install everything, which actually I can demonstrate it. So if I deactivate, I'm going to create a new environment. Python 3-m, then
Zainab, if you deactivate, shouldn't that be off your local then?
say it again.
I thought if you deactivated, you exited the virtual environment, right?
Yeah.
So why is simplest servers still in your local?
Simplest server. So the environment doesn't really have too much to do with your path. I mean, so this is my path because I am inside of this folder. What this virtual environment does is when I put these commands in, it'll kind of pipe it through there. If it sees anything that is like Python related, anything that we need to pass it through the virtual environment is holding all the Python dependencies and all that stuff. So if I'm doing something Python related, it'll go through this. But if I'm just saying like CD and like PWD, like making directories and stuff like that, that's just affecting my file system. It has nothing to do with the virtual environment. So the virtual environment is only taking, or is only helping us with our Python, pretty much. It installs a certain version of Python that allows us to keep our libraries and our libraries and modules contained for a specific project.
But everything is still on our local drive.
Yes.
Okay,
Yeah.
gotcha. Thank you.
Okay, so if I create a new environment here, and then I can activate it. Oops. Then activate. Okay, I'm in my new environment. If I do pip freeze, I shouldn't have anything in here. And then if I do pip install -r, my requirements .txt, it should now install all of those dependencies. Oh, I didn't press enter. Okay. So yeah, it installed these, and if I do pip freeze again, now I have modules or libraries installed here.
Why didn't you have to look back into the path of the other virtual environment?
Say it again.
Why did you not have to look into the path of the other virtual environment?
Because we created a requirements.txt file that is in our project folder. It has nothing to do with our environment. It just holds, it's literally a text file that holds the library name and the version that we're using. And so this line here, pip install -r, and then the name of that file that we had, we'll go through the file one by one and then install every single requirement in there. So it's pretty much one virtual environment. Just think of it as if this old virtual, this one, my env, this one was on my machine, and let's say this new environment is on Adam's machine. So all Adam has access to is this requirements.txt because I included it in the project. And that's how he will know how to set up his virtual environment by simply doing this.
So he'll get the directory structure, he'll copy it on his machine, and then he'll absorb that as a project and run the requirements file.
Yes, yes. So the project itself, so I'm gonna delete this environment. Hold on. So it doesn't get too, oops. Why am
Can you
I
delete that without deactivating?
Huh?
Okay.
Yeah, I didn't know where I was typing. Okay, I'm just gonna delete this right now. All right. So pretty much what is happening here, we're creating a folder, or Django is creating a folder for our project. So all of our code is going to be in this folder. When I did the pip freeze and piped it into the requirements doc, that just added a text doc that is now inside of our project folder. So this is just all of our Python files and stuff like that. So this will be, let's say, pushed to GitHub, this part. And then whoever is going to utilize that code will then install or download or clone this folder, pretty much, this project. And then we will, then that person will use this requirements.txt to set up their environment.
After they've initialized it in Django.
No, so what do you mean? Initialized what? The virtual environment or the project?
I think I get it. I'm okay.
Yeah, the virtual environment stuff is a little fuzzy, but all you have to know about the virtual environment is that it allows you to use a version of Python for your project. So if you use it in this way, you will contain your Python libraries and stuff like that within this version of Python. So you don't have to worry about issues with using it with other projects as well. More questions?
I'm sorry, when did the requirements.txt get created again?
When I did this, where is it? This. So this command does pip freeze. Pip freeze spits out all the dependencies, all the libraries that we're using right now. And this takes whatever output that was going to go into the terminal and puts it into something. And that something is going to be a file called requirements.txt. So you can name this anything. I believe this is the standard that pretty much everyone knows what a requirements doc is, or requirements file. More questions? Okay. I'm just going to activate my virtual environment again. Okay. So this didn't work right now because I'm one more level in, so I can't really access my virtual environment. So my path was wrong. So I have to do .. which will go up one level, and then my environment, binary, and then activate. Why isn't it auto-completing? Okay. Activate. Oh, I forgot to put source in the beginning. So source. There we go. So activate, what it does, it just turns our it pretty much allows us to send whatever we're gonna type in here through our virtual environment. So if we're doing any Python commands, it'll catch the Python information that we need and give us yeah, allow us to do what we want correctly. Okay, so we create a project. So I'm going to go over it one more time. To create a project, you do Python -m. So we're going to access the Django module, Django, and then Django has a start project one, and then you just give it a name. So my project name is Simplest Server right now. Okay. So now to start the project. To start the project, all you have to do is be in this folder here. So I know it's a little confusing because it creates another folder with the same name inside of it. But you need to be in the biggest folder here. And this is where we're going to call the manage.py file. So we're going to say Python manage.py. And then we're going to say run server. So manage.py has certain commands that you can run with it, and it will do certain things. So run server is okay, this is fine. You have unapplied migrations. We'll talk about migrations later. We can still run our code without it. So our server is running, and it's running on my local host and on port 8000. So let's go here. And just close out. all of this stuff. Okay. So if I go localhost 8000, there we go. This is our main Django page. And this page is there by default. I think they have an admin page already figured out too, or already in there. This won't be too exciting right now. We'll look at it when we start working with data, because it allows us to get insight on our database straight from here, through an admin panel, which is pretty cool. But yeah, this is our main page. Super simple, right? I'm kidding. Okay. Let's take a little break and just ask some questions, make sure all of this makes sense, and then we'll actually see how we can handle browser requests. Yeah, Ken.
Sorry, I didn't mean to clap react there. And I was just trying to raise my hand. But so we're referencing Django as a server, but the way that we just popped it out there, it looked like it was just like an HTML page. And so I'm just trying to figure out, I guess, really what comes next. Like why? I don't know, I'm kind of lost in the sauce here.
I know. So basically there is, this is like hard coded. We're gonna replace it with something else. So when we do our local host, our URLs will tell us where to go. It'll make a little more sense when we start coding with it.
Okay.
Yeah. So right now, all you have to understand is how the virtual environment is kind of working, and it allows us to create a Django project and keep our libraries contained. So far, that's the content that we've focused on. Thomas?
Would you mind scrolling up on your terminal just to your last, yeah. Okay, thank you.
Mhm. Yeah, Lewis.
So we only need the environment, the virtual environment, just to create. Download Django.
Yeah, to download Django and to download any other libraries that we are gonna use.
And that's it.
Yeah, pretty much.
We're never gonna use it again.
No, so we're only gonna use it within the context of this. We're gonna use it to run our project. So we're not just gonna like start up our project and never use the virtual environment. When we're working on our project, see, I ran here when I ran the server, it's still within my virtual environment because my virtual environment has the information my project needs to run. So whenever you're doing stuff in Django, you will have your virtual environment on.
Okay.
Other questions? I think someone asked earlier if you have to be in the folder, in the same folder as your virtual environment to activate it. You do not. As long as you provide the correct path that leads to your virtual environment, you can be anywhere. Yeah. I saw a hand go up. I think I missed it.
I kind of changed my mind, but so I guess just trying to wrap my head around it. So HTML is like the face of the website. CSS makes it look nice.
Mhm.
JavaScript makes the web page interactive. And then Django is what
So Django is going to
makes it like individual, kind of like on Facebook, everybody has an individual feed. Not everybody has the same feed, right?
Yes. Well, so Django is going to handle our data, like getting data from APIs is going to be mostly done in Python because a lot of front-end environments don't really allow us to access all APIs, and that's for like security reasons and stuff like that. So pretty much what Django is going to be, it's going to be our server. So we've talked about the server client relationship. So a full stack application is an application that has a client side that the person, like a person, interacts with, and then it also has a server side which feeds the front end. So all your data is going to be handled in your server side. Backend, you're doing data manipulation. Your let's say your user needs to sign up. So you have a sign up sheet on your front end. You're taking all that information from your front end through HTML, JavaScript, all that stuff. So now you have your information. What you're gonna do is you're gonna send it to the backend, and that information will then be saved to your database using the backend. So when we're writing a backend, server, that is kind of what it's doing. It's just allowing us to not have to worry about handling the database information on the front end. So yeah.
And then the reason we create our own environments on our computers is so we can download Django individually to that environment and configure it to that individual project. And we can have multiple projects and save it to different environments with different configurations, right?
Yes, exactly. So
Cool.
let's say this project needs pandas and like a lot of like data sciencey type libraries, and then I'm working with another project that needs a lot of like visualization, or like maybe it's a game and it needs like a lot of libraries that help you make like 3D animations or 2D animations on a screen. So you can have different virtual environments to do different ones. Yeah. Did that answer your question? Was that?
Yep. Awesome. Thank you.
Thank you. Jim?
So we may pop these open and close numerous times. If we have one project, we want to experiment one thing, we can open that up, close it, and then open another. We can save our progress.
Yes.
So let's say you have a project you like, can you initialize another project with data from a previous one?
Yeah, you could. So you're talking about like initializing it with the libraries, right?
Yeah, I guess I wasn't thinking of that. Can you copy this directory structure into a different folder and initialize it as a different name?
Yeah, definitely.
Yep.
It would probably be better to. So Django does a lot of things for you. So if you're not simply changing this outer folder name or this folder name might cause some issues within the settings, because there are things that are already configured for us using the names that we provided. So when we're creating projects, that's why we use the start project command and the start app command. Those allow us to not have to worry about any project configuration on the like behind the scenes. But if you want to copy the structure, you would probably have to go into the files that you actually write code in, and then you can copy those over, and then it'll do the same exact thing.
So that can you have two virtual environments up at different port numbers, and could one read information from another?
Yeah, so the virtual environments has nothing to do with the ports, but you can have different virtual environments in your terminal. So the virtual environment can be turned on and off in your terminal, in your shell. So yeah.
Well, it seems like this one's initialized at port 8000 for 127.0.0.1. What if you initialize one at 8001 then, or 8010? Can one virtual environment read data from another though?
So it's not the virtual environment that is on this port, it's the server. It's our project server. So Django created a bunch of stuff that allows us to run this command, and it runs a server for us. Kind of like how we were doing the HTTP server, you know, like that HTTP module server or live server. So those spin up a little server for us, but we don't ever see the server code. This is the server code. Like inside the project, here is all the stuff that is creating our server, and we are going to be configuring pretty much a server. Did I get to your question? I kind of like talked about that, but yes, you can.
Yes, very cool.
You can run a different terminal in a different project, and it'll probably run on a different port because this one is being used. So I think the default is 8,000 for these, but if it's not available, it'll go to the next one that's available. Great questions. Kenneth.
So I'm feeling like Django is more of like an emulator, and it doesn't, or like a dev tool for us, because it doesn't actually host anything of substance. Like if we actually wanted to make this a live real-time application, Django won't do that. But in the meantime, we can use Django to sift through and make those calls and whatever.
So
am I on the right?
Not quite. So big picture, Django is your server, and all you have to do is take your project and put it on, like host it on a server, or host it on a computer. Like, yeah, you can host it on AWS, you can deploy it, and then you have to just change a few configurations that allow you to visit a certain domain. So you have to have a domain name, you configure the domain to this, and now if you go into your browser and you call, that was not what I wanted to go. So if you call simplest server.com, that will then take us to our server. Yeah. So right now, because we don't actually have it deployed anywhere, we are going to access it through localhost on port. Yeah. So
that makes sense.
Will be replaced once we get into the deployment, which we'll talk about later in the course. Yeah, a domain name that we configure will replace this. Yeah.
Awesome.
More questions? Yeah, AWS is Amazon Web Services. It allows you to not have to worry about buying like physical computers to run your applications on, because so when all these websites that you go to, like you can go to them at any time in the day and you would be able to access them. They're up. And that is because they are running 24/7 on a computer somewhere. So back in the day, they used to have, back in the day, each person who wanted to make a website would have to have like a physical server, a physical computer that they will have running all the time, and your program will be running on it. So your project is going to be accessible from the internet at any time. So there's a lot of cost attached to this, cost and maintenance, and if your website grows, you need to buy more servers because you don't have enough space. So that's why cloud providers are very, very big now, because people don't want to deal with that. So I don't know if you guys have seen a data center, what a data center looks like. But a data center is basically just rows and rows of computers. So each of this each row is its own server. It has like a CPU, RAM, just like regular computer components. There are no screens because people aren't actually accessing them through screens, but they're all attached to each other through a network. They all have different names, and then they're all stacked up on a rack. And then in the data center, there's just a bunch of racks, just rows of racks that are available to be used. And so what cloud providers are, is they act as the middleman. So you go through them pretty much to grab a server from somewhere. So let's say Amazon has like huge data centers because I don't know, in their busiest time, they need like this amount of servers, but in usual times, they only need like a small portion. So they end up renting them out to people. And they're like, okay, well, I'm not using it from this hour to this hour, so it'll cost you this much to put your application on my server and use my resources. So yeah, the cloud is not some ominous thing. It's all computers connected with wires. Even if you're going across the world, there's what was it called? Underwater internet cables. So the internet gets all the way across the world through actual cables. And there's a huge network just running at the bottom of the bottom of oceans. And they're very vulnerable to just wildlife, and like a lot of times people lose internet connectivity because a shark bit into one of the cables, and now there's there's an issue with the cable. Or ships dropping anchors. Yeah, that's a pretty big thing. So this is exactly what it looks like. There's just cables running in the waters, which is pretty cool. Yeah. Questions?
Just a fun fact. It's interesting how data travels now. They use lasers.
Yeah. Oh, let me show that. So a fiber optic cable is, I think it's, yeah. So fiber optic cables are basically like thin, I don't know what material, it's like a fiber, but basically they send light through it. And that is how things get transmitted, versus coaxial cables, which you guys have definitely seen in your house. It's attached to a cable box, or it's attached to your modem. This actually sends over voltages. So it sends like electrical voltages, and that's how the information is sent. Yeah, flexible glass. That's what the fibers are. So it's like a flexible piece of glass, and they shine a light from one end, and that's how you get the information to the other end. It's more complex than I'm describing it, but that's effectively what it's doing. What else? Okay, give me a sec. All right, so before the break, we had just created a project, and we did a pip freeze to hold on to our requirements on the side, and that's pretty much it. So we can run our server again just to see what we get. So manage hi, and then run server. Oh, I'm in the wrong directory. So I'm in this one, I need to be in the project one that I had created, this one. So I'm up here. So cd simplest server, and now I can run that command. Okay, so my server is running. I check here, refresh. Okay, so this default page shows up because we haven't set any route configurations. So a few things I want to mention. So yes, Django does, so Django gives us a web server that we're going to be using for development. I just wanted to reiterate this, and when we deploy it, then we're going to put it onto a server that will allow us to access it from the internet for long periods of time. All right. So what we want to do is, let's say when we get to our homepage here, we want to see something that we return. So remind me, what happens when I put a domain name here? And I hit enter. What happens? Like if I said google.com and then hit enter, what
You make
happens?
a request to the server to return a page to you.
Exactly. So this is doing the exact same thing. So localhost right now will go to our Django project, and we have not set any URLs yet. So there's an admin one. So if I had gone to /admin, I will see an admin page. And actually, I don't remember what the, yeah, it's fine. I don't have this set up, so it's not a big deal. But basically what we're gonna do is we're gonna configure certain route handling methods. Usually our URLs are going to be held in a urls.py folder, a file. So we are going to go over on Monday the action, like the proper way to structure your projects and all that, which I mentioned about the apps. So we would usually create an app and we would have our app specific routes handled in there. And this one, the one with the main module, this will be holding references to that file. So if we had multiple apps in this project, this will have 2 entries. One would be a reference to one of the urls.py, and then the other one would be a reference to the other apps urls.py. For now, we're just going to do everything in this file, just for simplicity's sake. Yeah, so this is usually like a table of contents, where you only have like the page, the chapter name and page number for that chapter and stuff like that. Okay, so to start off and to make a path, we're going to use the path keyword here, or the path method, and then we're going to put what the path is. So I'm just going to put an empty string for the base path, and then I'm going to call a function here. I have not created this function yet. I will just give it some name. So maybe I want to call it, sorry about all the pop-ups. My route handler, which this is Python, so I should follow syntax. Okay, so this doesn't exist. So I'm just going to create it here. Again, usually these methods are also in a different file, but yeah, just for today, we're going to put everything in one just so we can see what is happening. So route handler. Actually, a lot of times we end up calling this index. So I can just call this index right now. And this one, so what happens here? If we go to our base path, whenever we go to our base path, this function gets called, and this function will have the request from the browser sent in with it. So we will have access to the HTTP request, and we are going to be returning an HTTP response. So we can create an HTTP response through a specific library. So import, I'm going to turn this off because every time so this is the time where you will probably need to turn off your autosave, because the server refreshing is going to drive you crazy. So I can run it and then I can, okay, so I'm going to import something called Django.http, or this is the main name, and I'm going to import HTTP response over here. So this formats it for us. We don't really have to worry about doing all the formatting of the HTTP response. All we have to do is send something in. So I can send in just a string saying hello world, because we're exploring something new, so we have to. I think it's law. So now if I refresh, we get hello world. So can someone walk me through exactly what happened when I went to this URL? No one wants to take a crack at it.
We're not seeing hello. Oh, there it is. Okay.
Yeah, hello world right here. No, come on. Okay, so in our URL bar, in our browser, we made an HTTP request to localhost. Our urls.py captures these requests, and then it tries to match your request with the URL patterns that you have specified previously. So because we didn't have this here before, our main one, our blank path, so just plain old localhost port 8080 or 8000, that went to a predefined page that Django gave us. But now, since we defined that we want to do something with this path, we provide it with a function that will handle a request. We're not actually doing anything with the request at the moment, but we are sending back an HTTP response because, again, this is an HTTP request. We are sending back a response with a string saying hello world. And when we send it back, this is what's going to be displayed. Pretty cool, right? I think it's pretty cool. So within this HTTP response, you can also send in just like HTML, regular HTML. So I can say this one is going to be an H1. This is not how we are going to be writing HTML with Django, by the way. This would be a pain if you have to return everything in strings. We will probably touch on that either Monday or Tuesday, where we have templates where we create these HTML files and we can send information back to those files. Okay, so now if I save this, it refreshed, I go back, I refresh my page, and now it's a header. Okay. So let's try. Okay, so we can create the response instead of just returning it. So we can say response equals this. And then, so response has access to response type stuff. So we can access something called status code, which we've seen before in HTTP responses. And this response, let's say I want to put 201, I don't know why. Then I can return response. Okay. And so if I do this, we're not going to see anything change here, but if I go into my dev tools, let me move it to the side. Go into my network tab and refresh. Am I not seeing? Oh, because I was filtering it. Okay. So it said the status code was 200. Let's see in here. This is my response. Okay, I might have done something weird. We'll we'll get back to that. Okay, so let's remove this. It's not really doing anything right now. So let's see what's actually in our request and response objects. So it automatically parses the request as a Python dictionary, I believe. So if I say, so we've seen vars before, which gives you the variables and stuff inside an object, but dir gives you the names of methods and attributes that are available as well. So let's look at the request information. Yeah, and so so this is a way to debug these programs. So when we go back to our browser and request the same URL, it's going to go into the function, and then this print statement is going to print here in the console. So if I run this again, we're not going to see anything in this console. This is empty because we're not printing anything here. But in here, we see a bunch of stuff just got dumped out. So our request has a bunch of methods, and so these are all, the built-in Dunder methods. There's a get, there's a post, cookies, meta. Yeah, all this fun information. You have session, user, path, get host, all that stuff. We won't be using too much of it, but it's important to understand or to know that they're there. Let's also print. I mean, you might use a lot of them. Yeah, I'm just gonna do that. Oops. So let's see what the response creates. Oh, I forgot. I have to save it here, and then I have to trigger it again from here. And now this is the information that is inside our response that was created. So let's see if there's anything that we know. Can set cookie. So remember how we were talking about cookies, and that when you make a response, the server will send you back the cookies to set. It'll create cookies for the client to create. So this would be the attribute that you would set. Yeah, anyways, this is just to see what is inside of here. Questions on this so far? We haven't really done much, but. All right. Okay, so let's say we want to create another one. And these will always take the request in because they are handling our HTTP requests. And then say we're going to return something here. Return another HTTP response saying something else. And what should our path be? Just give me any path.
Home.
Home, okay. So home, I think I have to put a slash after it. And then this is called another route handler. Okay. And the reason why we don't put the parentheses after these functions is because we don't want these to be called when this is created. We just want to say that we're sending in a function, and then it'll handle calling it whenever it needs to, whenever we actually go to this path. So now if we go to this path and we write /home, we will see something else. But yeah, so we can make as many routes as we want. I'm gonna copy over this one example here. We're probably just gonna be returning the response. So you can put a different one. Yeah, the status code thing was weird that it couldn't. Oh, nice. So we got the status code, the different status code. And I actually didn't show you guys this one status code. It's just, I'm a teapot. And it was an April Fool's joke that someone had written, where I think, like, if you're talking to a smart coffee maker through HTTP, it's supposed to say like, oh, I can't make coffee, I'm a teapot, or something like that. I don't know. It's funny. This is probably from one of our previous instructors. Yeah, that's, so the status code thing worked now. Maybe 201 was not a valid status code. Okay. So these are, what type of requests are these?
Get requests.
Exactly. So we can do, let's print the request dot get. So there's a field called get, and actually let's print out what that has. It's a query dictionary. I'm actually not exactly sure how, like, what all is in the .get, but in the example that I have here, we have the get format. Let's see what this does. Okay. There's none as formatting. Hold on. Oh, okay. Never mind. This will happen with the next example. Okay. Sorry, I got a little confused. Okay, any questions on this? Just the fact that you can define what your routes are, and then you can create a function that handles it. Yeah, Jacob?
So we're writing this in Python, and I'm assuming Django takes the HTTP response and is converting that to HTML. Is that, how is that, you know, turning into a visible HTML page?
So it's not this is not an HTML page. This is just an HTML element that was returned. So if I looked at this,
yeah,
the response was literally just this. So I didn't actually return a file, but I returned an element inside the HTTP response. And that is basically what.
Can you show us again where you made that happen?
to return this.
Yes.
Yeah. Okay. Up here. So I defined this function. I created a response, and inside of this response, I set whatever information I want. So I can put, I think if you put 3 quote marks, you can actually do a string on multiple lines. So that is kind of helpful for formatting. But let's say I want to do an H1. So this, yeah, I don't know how in the back end it does it, but it interprets these elements outside of an HTML. So it's not inside of an HTML page, but it somehow knows to interpret them. I will learn more about it, and I will come back to you guys with that. So yeah, I think I created the right element. Now if I go back here, and it's just, yeah, so you can just return whatever elements or whatever string, because even before I didn't return an element, I just returned a singular string before.
Sure.
Yeah.
But if you inspected the element on the page, it would look like HTML then. So Django is doing something to make it basically HTML.
Yeah, it is. So we're not creating it, it somehow like sends it through. I'll learn more about the mechanics of it. But it'll become a little more apparent when we actually create the HTML files and we're rerouting to those files specifically. That'll make sense more. Yeah, Thomas.
I was just curious for naming convention wise, when we create the functions to handle the individual route requests, would we name them something relevant to whatever we're doing, such as like, I don't know, home request versus?
Definitely. So this one probably want to call, I don't know, get home. Yeah, get home or reroute home or something like that. And yeah, I agree. Yes, that would be. Yes.
Okay, thank you.
Other questions? Okay. Let me read the one in the chat. So we import libraries from Django, define our routes, which are the paths, and then define functions to handle the route requests and set custom responses in those functions containing whatever information we want to display. Yes, that is exactly it. That is the flow of how they work. All right. This is our last example, which is good because we're right on time. So let's say we want to do the same one. So, or not the same route, but a similar one, but I want to actually be able to take in a parameter. So to define a parameter, you have to put the angle, what are these called? I don't know what they're called. These things. And inside of them, you define the type that you're bringing in. So if I was bringing in an int, I would put int. If I'm bringing in a string, just str. I don't know of any other ones. Maybe you can do like a float or something. We'll look into it later, but mainly in your URL, you're mostly gonna see a string or an int. So let's say I want to call this name. So you give it a name here, and then I'm going to I'll get home with parameters, and I'm gonna, oops. Oh. So I'm gonna define a function with that name. Gonna take in the request. And I'm just gonna write password now, so it, or I can just return. Okay, and so to capture these parameters, you just put a comma here and you say what you use the name that you defined here. I believe you have to use the same name. Actually, let's try name 2 and see if that works. And then I'm going to return an HTTP response that has, let's say, oops. I'm actually just going to do a header. Hello, and then I'm going to add the name. Let's see. How do we do this in Python? I think this is how it's done in Python. I forgot. I've been doing JavaScript for 1 week and I forgot Python again. That's fun. Okay. I'm just going to call this response equals, and then I'm going to return the response. Okay. Leave these empty lines. Clean it up a little bit. I actually don't need to do this necessarily. Okay.
I think you might need the F on that string.
Thank you. That's what I was forgetting. Okay. Awesome. So now if I just do home, this is the same element. If I do home slash my name, what is the issue here? Also, the errors are a little weird. So if there was an error that happened, if you see here internal server error, you will find your error here. So what did it say? Got an unexpected keyword argument name. Okay, so this is what I wanted to test out. It's because I used a name here and I changed the name here. So this is one of the cases where you actually have to make sure that it's the same name that you defined.
Can I ask a question real fast?
Yeah.
Why do we not have to close the H1 tag?
Oh, that is gonna probably give me another issue. That's just me. We do. Okay, let's try that one more time. There we go. So now we were able to grab our name from the parameter and insert it into our HTTP response. So this is what I wanted to test out before. One sec. So if I put name, so I can access this name through the request. So request.get, this second .get is the way to get something from a dictionary, which we should be able to just use the square brackets instead of that. So let's test this part out. Too many parentheses. Okay. What did I do? Exception name. Oh. Yeah, I think it's a certain type of dictionary, so we have to use a .get method that will get a certain value for us with a specific name. So let's try this. There we go. Okay, so we didn't get an error, and then it printed out none, which is weird, but that means it has access to it. I will.
Could it be because it's getting done because you're printing and then returning at the same time? I don't know if that has anything to do with it.
Yeah, the print goes here, which I see it. So I see none. But I don't know why this is none specifically. So yeah, I think I just need to do a little more research on the Git and having access to certain parameters and stuff like that. Yeah. Questions? No? Let me pause this.